Okay, kids, we are continuing what we did with the previous lesson. And so it's really not much new. It's just practice opportunities so you can become an expert in all this graphing business. Okay. Remember, there's some things that we can determine immediately. This equation is in standard form. Most of these are in standard form. The value of A here is this invisible 1. It's positive. That means it opens up. The y-intercept is this thing hanging off the back, because all y-intercepts have an x value of 0. So if the x value is 0, that goes away, you just have 24 left. So, whoops. So those things you can determine right away. So here, let's look at B. We can, same thing here. Does this open up or down? There's an invisible 1. Opens up. Okay, this is the y-intercept. So when you're in standard form, you can determine whether it opens up or down and the y-intercept immediately. Okay, now the next thing, the vertex, that's a little bit more work. Remember, the x value of the vertex is the opposite of b over 2a. We talked about that the other day. So here, the x value of the vertex, the opposite of b would be negative 10 over 2 times a. Negative 10 over 2 would be 5. Whoops, sorry, negative 5. Okay? Now, remember, that's just the x value of the vertex. Okay? There's also a y value. Now, that y value, if you remember, you have to take this x value and plug it in to figure out what this comes out to. Okay? Now, I can do this in my head. You guys might want to use a calculator. It's up to you. If I have negative 5 and put that in here, negative 5 squared is 25. 10 times negative 5 is negative 50. So if I have negative 25, positive 25, negative 50, and positive 24, that's all going to come out to negative 1. Again, I have negative 5 squared, which is 25, plus 10 times negative 5 plus 24. That would be 25 minus 50 plus 24, which is negative 1. So that's the vertex of my parabola. Equation of axis of symmetry. It's always x equals whatever this x value is every time. Find the zeros. Remember, the zeros, that's the x-intercepts. So replace y with 0. And then this looks like it's something that would be factorable. And it is. If I use 6 and 4, gosh, sorry about this. If I use 6 and 4, these are both plus. My zeros are negative 6, and my second one is negative 4. So those are two critical points. Negative 6. 1, 2, 3. There's the negative 4. There's the negative 6. Remember, earlier we had found the y-intercept to be 0, 24. Well, that's going to be super high off the graph, so don't worry about that. Okay? The vertex was negative 5, negative 1. So we only have the y-intercept so far up there. We only have these 3 critical points, and that's okay. All right? I mean, there is a fourth one, but it's just so high off the graph, we're not going to worry about it. Okay, back here, we'd started this one. So the vertex, remember, opposite B, in this case, would be positive 2 over 2 times A. 2 over 2 is just 1. Plug that 1 in. 1 squared is 1. 1 minus 2 would be negative 1 plus 1 is 0. It comes out to 0. Axis of symmetry is x equals that. I'll draw the axis of symmetry in this next one. Find the zeros. Well, again, replace the y with 0. So I get x squared minus 2x plus 1. I'm going to try to factor. And 1, both are negative. I only get one solution here, 1, 0. So that's at x equals 1. So that would be right here. And you know what's interesting is that is the same point as the vertex. So one of the solution and the vertex match up. Now the y-intercept, if you remember, that was 0, 1. Now remember, there's a mirror image right over here. So let's go ahead and show that. And we're going to graph this one with just 3 critical points as well. Okay? I told you I'd show you the axis of symmetry. Remember, the axis of symmetry is not actually part of the parabola, but it would be this vertical line that goes right down through the vertex. All right? That's it for those two. And again, today is just a practice day, but you see, things look a little bit different on this next page. This doesn't look like the traditional standard form, does it? And the reason why, I hope you realize, is that it's just that it doesn't have a b term here. The b value would be 0. Same thing with d. So it's still in standard form. Open up or down? Well, this invisible thing in front's invisible 1. It's positive, so it opens up. Here we got positive 9, opens up. Y-intercept is this number hanging off the back, the constant, 0, negative 25. And here it would be 0, negative 16. So even though it looks a little bit different, it's still standard form. It's just that the b term, the x term, is 0, so it's not there. That makes calculating the vertex easier. See, the b was 0, so the opposite of 0 is still 0. Over 2 times a, well, 0 over anything is just 0. And then figuring out the y is easy as well, because when you plug 0 in here, 0 squared is 0. 0 minus 25 is negative 25. Axis of symmetry, which always x equals that. Okay? Now, finding the zeros, replace the y with 0. Now, you see, there's no b term here. Remember, when there's no b term, we solve using the square root method. So we want to move this over by adding it to both sides. And then we take the square root, but remember, our answers are positive or negative 5. So my zeros, 1, 2, 3, 4, there's the positive 5. 1, 2, 3, 4, there's the negative 5. Okay. My vertex and y-intercept were the same thing, and it's super far down there. It's like 0, negative 25. So, it's gonna be way down here. So I'm just gonna improvise, and I'm just gonna kind of draw something like that. That's not really to scale. It would probably be even lower than that, but I'm just doing the best I can. All right, so we only had 3 points there as well. You don't always have 4 critical points. Okay, here, the vertex is, again, opposite b. B is 0, so that's easy, over 2 times a, but anything over 0, anything under 0 is just 0. And if I plug that in, I get 0, negative 16. Axis of symmetry is just x equals 0. It's just these problems are exactly like each other. So now we get, replace the y with 0. We don't have a b term, so let's move the 16 over by adding. Get the x squared by itself. But remember, these are both perfect squares. So when I take the square root, I get 4/3, but remember, that's actually plus or minus. Now, graphing that, remember, you have to think a little bit. 4/3 is a little bit bigger than 1. 3/3 would be 1, right? So 4/3 is a little bit bigger than 1, so we're just going to estimate. That's going to be about right there. Negative 4/3 would be similar right over there. a little bit past the negative 1. And our this is going to be a really steep parabola, and that's because of that number 9. Remember that number, that a value, if it's farther away from 0, the parabola gets steeper. Negative 16, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's like way down there. So we have this super steep parabola. And again, that's because the a value was so big. But these two problems are really exactly alike. Okay? There we go. And we got the last page now. And we can handle this too. Now this E is more traditional. Looks, we got our regular ABC. We got another one that opens up. That's amazing. We've had a ton of these. Because we got this invisible 1. Y-intercept, of course, is 0, 2. All right. Let's do this one. Oh, we got to be careful with this one. This was not written kind of in the typical manner. If I write the x squared term first, it would look like that. So this one's going to open down because my a value, which is in front of the x squared, is actually negative. This y-intercept, remember, it's the number at the back with no x. There is none. And that's because the y-intercept is 0. Okay, vertex. X equals the opposite of B over 2 times A. That comes out to 5. Now remember, that's just the x value of the vertex. You got to plug that in. 5 squared is 25. Minus 50 plus 2, you get negative 23. Okay. So the axis of symmetry, whoops, find the zeros. Now this one here, x squared minus 10x plus 2, there is no way this one's going to factor. There are no factor pairs of 2 that are going to give you that negative 10 in the middle with a leading coefficient of 1. So I'm hoping that you guys realize that means quadratic formula, x equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. Now everything in that square root comes out to 92. And again, now you're going to use your calculator, your Inspire. You're going to do this thing twice. You're going to do 10 plus the square root of 92, hit enter, then divide it by 2. Then you're going to do just 10 minus square root of 92, hit enter, divide by 2. And you should come up with 2 answers. You should come up with 9.8, and you should come up with 0.2. Those are our x-intercepts. So 0.2 is going to be like, really close to there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9.8 is going to be out here someplace. Remember, my vertex was 5, negative 23. So that's really down far, way low. You guys remember what my y-intercept was? My y-intercept was 2. So I'm just going to draw my, you know what? This will help me draw this. I'm going to put my axis of symmetry. Because I know that 1, 2, 3, 4, 5, the x value of the vertex is 5. I know the axis of symmetry is there. That'll help me draw a better parabola because I know I need to bottom out symmetrical to this thing. There you go. Okay, now the vertex is actually going to be a little bit lower probably. It's not drawn to scale because negative 23 was pretty far down. All right, this one won't take us long. The vertex We have to find that. Opposite of B, remember B is 16. So opposite is negative 16 over 2 times A. That's negative 16 over negative 8, which comes out to positive 2. Now I'm going to plug that in. 2 squared. 2 squared is 4. 4 times negative 4 is negative 16. 2 times 16 is 32, and negative 16 plus 32 is 16. So this is x equals 2. Now don't make this harder than you need to. Remember, we had what? Replace the y, negative 4x squared plus 16x. You know, I'm thinking GCF here, folks, but you know, I would like to multiply both sides by negative 1. That way this leading coefficient is going to be positive. So I get 4x squared minus 16x. Take out the GCF, and Shazam, x equals 0, x equals 4. 1, 2, 3, 4. There's the 0. Now remember, what was the vertex again? The vertex was 2, 16. So that's going to be way up on this axis of symmetry someplace. Pretty high. We can probably... And remember that I didn't show the y-intercept is the same thing as one of the zeros. So where is 16 going to be about? 1, 2, 3, 4, 5, about right there. Boom. Okay. That's it, folks. Remember, live Zoom lesson every blue day, beginning at 1:30. See ya.